Okay guys, welcome to highschoolmaths.co.uk. Today we're going to look at the 2018 National 5 Paper 2. And here we've got, it starts off, a little compound interest question. So the households in the city produce a total of 125,000 tonnes of waste in 2017. Total amount of waste is expected to fall by 2%, so it's going down by 2% each year. Calculate the total amount of waste these households are expected to produce in 2020. So we're looking at a 3-year cycle there. So we're starting off each time with 100% and we're taking away 2% of the waste, so it's decreasing by 2% per year. That means we've got 98%, so it's 0.98 as a decimal at the end of each year. So for a period of 3 years means 0.98 cubed, and then we're multiplying that by 125,000. That'll tell us exactly how much waste there will be after 3 years. So 0.98 cubed times 125,000, and that gives us 117,649. Okay, and there's no rounding or anything required there, so that would be our final answer in tons. Okay, question 2. So we've got the diagram below shows a sector of a circle, center C. So we've got a sector of 320 degrees, sector C, radius is 7.4, that's in the diagram. Calculate the length of the major arc AB. Okay, so it's looking for this distance around the perimeter of the shape. So, arc length equals angle over 360 times pi d. So in this case, that's going to be 320 for the major section or sector over 360 times pi times 14.8. If you type that into the calculator, that should give you an answer. So 320 divided by 360 times pi times 14.8, and that gives us 41.33. That's centimeters. Let's check that there was no rounding required. No rounding required, and that's the question completed. Okay, question 3. Find the magnitudes of r, given that r in component form is this. So the magnitudes of r will be the square root of the components squared, or the sum of the components squared. Make sure we put the negative number in a bracket when we're squaring. So if we find the value of those three terms squared, so 24 squared plus negative 12 squared plus 8 squared, and that gives us 784. And then we just square root that answer. That gives us 28. So the magnitude of that vector would be 28. Okay, solve the inequality or an equation. So we're going to multiply the brackets first. So that gives us 6x minus 6, and then minus 12 outside the bracket stays the same. We're going to collect like terms on the right hand side, so the negative 6 and the negative 12 combine for a negative 18. We're going to take away 6x from both sides to get that expression, that equation or inequality there. Dividing by negative 3, where you have to be careful. When you divide by a negative, then you've got to flip the arrow. So negative 18 divided by negative 3 would be 6, so x is greater than 6. Okay, question 5. Farmers market took place one weekend. Stallholders were asked to record the number of customers who visited the stall. Calculate the mean and standard deviation. Okay, this is a couple of different ways to do this. I'm going to stick to one method. If you use a different method, you should still get the same answer. It'll just be a slightly different process to get there. Okay, you do have the formulas in the formula sheet, so you can use them as well. So first of all, the mean, which is going to be your x bar here, and that is just all the terms added together and then divided by 6 because there are 6 terms. So 120 plus 126 plus 125 plus 131 plus 130 plus 124. That gives me 756 divided by 6 because there are 6 and different numbers. So 756 divided by 6 equals 126. Good, we're working with whole numbers. That's always a wee bit nicer. So, my straight lines are just shocking. Let's try that, and we'll just use a straight line tool. Okay, so we're going for a table. Now, you may have seen this a different way, depending on the way you've been taught it. So I use the three column table where we've got x minus x bar, and x minus x bar squared. And x is the list of your numbers, so 120, 126, 125, 131, 130, and 124. X minus x bar is taking each number here and subtracting the mean, so -6, 0, -1, 5, 4, and -2. And then taking each of these, so this middle column shouldn't be x minus x bar squared. Oh my d, right, so that should just be x minus x bar. And then the last column is x minus x bar squared. So we're going to take each of these values and then we're going to square them. Apologies. So -6 squared would be 36. 0 squared would be 0. -1 squared, 1. 5 squared, 25. 16, and 4. What we're looking for at the bottom here is a total. So 36, add all these together. It is a calculator paper. You may as well use a calculator, so we don't make any silly mistakes when we're adding them together. That looks like it gives me 82, and hopefully I've not made a silly mistake. 6, add 1, add 25, add 16, add 4. Bingo. This is the sum of the x minus x bars squared. So this is the top line of one of the formulas in the formula sheet. So the standard deviation is given by the sum of x minus x bar squared all over n minus 1. So we're using that formula from the formula sheet. There is a different one which requires a different table, but you should end up with the same answer at the end. So here we've calculated the top line. That's what that table is all about, just making that wee process quite straightforward. N is how many numbers we have. So we have 6 numbers, take away 1. Let's write that down. And that gives us, so it's 82 divided by 5 really. And that gives square root of 16.4. We're then going to carry out that square root. So square root of 16.4 gives us 4.05. Keeping it to 2 decimal places, just to keep it as accurate as possible just now. So that's our standard deviation. That's our mean. Part B is probably going to go on to ask us to do a comparison. Okay, so saying the mean number of customers who visited these 6 stalls on Sunday was 117. The standard deviation was 6.2. Okay, so we've got to make 2 valid comparisons. So again, I would just bullet point my comparisons here, just to one for each mark. We're going to compare the mean first and then the standard deviation. So the mean's the easier one. Mean is a measure of average, so I would always start my comparison there with on average. And then we're looking to see, what was the first one? The first one was oops. First one was Saturday. So it's between Saturday and Sunday. Okay, so Saturday and Sunday, we've got on Saturday they had an average of 126, on Sunday an average of 117. So on average, less people visited the stall, or visited on Sunday. That's because the mean 117 for Sunday was less than the mean 126 for Saturday. The second sentence is comparing the standard deviation. So Saturday, the standard deviation was 4.05. Sunday's, the standard deviation was 6.2. So the bigger the standard deviation, the more varied or more spread out the measurements have been. So in this case, we would say the number of people this is for part B, number of people who visited on Sunday was more varied or more spread out, something along those lines. And that's because the standard deviation 6.2 is greater than the 4.05 that we calculated for the Saturday. Okay, good. So that's our 2 marks for that part. Question 6, a function is defined as f of x equals, given that f of a equals 73, calculate a. Okay, so if f of x equals 5 plus 4x, f of a is going to be 5 plus 4a. We're just taking the term within the bracket in the function notation and substituting it in wherever we have an x value. So f of a is 5 plus 4a, and it's telling us here that f of a is equal to 73. This is f of a here, and this is what f of a is equal to. So essentially we're just replacing this with 73 to get 5 plus 4a equals 73. We've just then got a straightforward equation. Take away 5 from both sides and we get 4a equals 68. Yeah, that's right. And then we're dividing both sides by 4 to get a equals 17. Okay, good. Question 7 looks like it's going to be a volume question. 6.4 centimeter diameter. Okay, let's scroll down. So we've got a big sphere there. Calculate the volume of the sphere, the juggling ball, to two significant figures in big bold writing. So volume of a sphere is given in the formula sheet, 4/3 pi r cubed. And we're just taking the correct value. So 4/3 times pi times the radius, which would be 3.2 cubed. So it's 4 divided by 3 times pi times 3.2 cubed. That should give you 137.258. Dot, 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 dot. Now we want that rounded to significant figures. Our first significant figure here is the 1, second is the 3. After that we've got a 7, so we're going to round up. So it's going to go to 140 cm cubed to 2 significant figures. Okay, question 8. Solve the trig equation. So we've got 7 sine x plus 2 equals 3. First thing we want to do is try and get the sine x term on its own. So I'm going to take away 2 from both sides. Get 7 sine x equals 1, divide by 7, and we get sine x equals 1 over 7. Then I'm going to jump over to a 4-quadrant diagram. A, S, T, and C. You might have a slightly different diagram that you use. We're going to tick off sine as positive, so we're going to tick all and sine. This is our 0 plus region, and this is our 180 minus region. And we're going to calculate the related angle for this trig function as going to be inverse sine, so sine to the minus 1 of, sine to the minus 1 of 1 over 7. This value is the value we're going to use to calculate our values for x, which lie within these 2 quadrants that we've ticked off. So inverse sine, so second function sine, make sure your calculator is on degrees, not radians. So we've got second function sine, and it's 1/7, so 1 over 7. And that should give you 8.2 degrees. Okay, so we're going to use that answer to calculate our remaining 2 values. So the first answer is just 0 plus. So 0 plus 8.2 is 8.2 degrees. The second answer is 180 minus 8.2. So 180 minus gives us 171.2 degrees. And that's our 2 solutions for that trig equation. Okay. Sorry, should have checked. Just make sure you check your answers fall within the region that's defined within the original question. So here it's telling us our answers have to be between 0 and 360, and they both fall within that region, so that is fine for this. Okay, looks like a trigonometry question. We've got a triangle with a line extending up for between A and B. 75 degrees given, 37 degrees given, BC is 20 centimeters. So all the information is in the diagram. Calculate the length of D to C. This is going to be our X. Okay, so let's fill in as much information we can. This is a straight line. If that's 75, that's going to be 105 degrees in here. And if that's 105 and 37, we do 180 minus both of them. That gives us 38. So this angle in here is 38 degrees. Brilliant. So we've got 3 angles in the triangle. That always helps. Calculate the length of D to C. So we're only given one side on this triangle. So automatically that tells us we have to use the sine rule. For either cosine rule, we need 2 or 3 sides. So let's use the sine rule. We're looking for x. So it's A over sine A equals B over sine B equals C over sine C. You're doing the side with the opposite angle. So it's x over sine 105 equals 20 over sine 37. And then we're just going to go through the process of solving that. So I would always cross multiply at this stage, so we're not dealing with fractions. So that gives you, this comes up to this side, this comes up to this side. Of course, there are different ways of doing this. Then divide by sine 37 to get our x term on its own. And then just type that into the calculator. So 20 times sine 105 divided by sine 37. Again, just take your calculators in degrees for that. So it should give you 32.1 for your distance there. And that was in centimeters. So 32.1 centimeters. Okay, great. Question 10. Okay, a bit of vectors work here. AB and EA represent the vectors U and W. Okay, nice diagram here. So this is W, this is U. E to D is 2 times A to B. Okay, so that means this line here is twice the length of this line here. All right, doesn't look right. E to D is twice the length of A to B. Yeah, okay, so this line must be 2U. Okay, E to A is twice the length of this line. Okay, so from there to there, it's twice the length of this line here to here. So if this is W, this has got to be a half of W. Doing that at the beginning when you're given this information will help a lot with the question, because the question is no doubt going to ask us to go through an alternative path that uses these two lines here. So it's a good strategy to help deal with this type of question. So we want to express BC in terms of U and W. So we want to start at B and we want to get to C. The problem is we don't have an expression for this movement in terms of U and W. So instead we're going to have to go all the way around. So we're going to start at B and then we're going to go to A. Now, if we do that, so what I'll do is I'll write out the vector pathway first. So B to A plus A to E plus E to D plus D to C. That's the way we're going to move. Okay, so that's how we're going to get from B to C. Now, B to A is negative U because we're going the opposite direction of the vector. A to E is negative W. E to D is 2U. And D to C is a half W. And just like algebra, we just collect like terms here. So we've got a negative U and a plus 2U. So we end up with a 1U or U. And we've got a negative W and a half W, or plus a half W. That gives us negative half W. And that's our resultant vector in terms of, so that's the vector BC in terms of U and W. Okay, question 11. Venus and Earth are two planets within our solar system. The volume of Venus is approximately blah 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 9.3 times 10 to the 11. So a little bit of standard deviation here. Standard scientific notation. Sorry, get my words mixed up there. So a little bit of scientific notation. 9.3 times 10 to the power 11. This is 85% of the volume of the Earth. Okay, so Earth's going to be bigger because Venus is only 85% of the size of Earth. So we're saying that 9.3 times 10 to the power 11 is equal to 85% of the Earth's volume. So 1% of the Earth's volume is going to be that divided by 85. So we do 9.3 times 10 to the power 11 using this scientific notation button. So that divided by 85, that gives us 1.09. 4 times 10 to the power 10, rounded. So we're going to keep that in the calculator, then we're going to multiply that by 100, that'll get us to 100%, and then that'll be, 100% will be the volume of Earth. Okay, so 1.094 times 10 to the power 12. Okay, it's not asked us, it's not required any rounding here. Sometimes that might be to a certain amount of significant figures, but it's not required here, so that would be our final answer. And that is cubic kilometers, so km cubed. Okay, good. Question 12. Okay, this is one of your typical circle with a bit cut out of it. Looks like you're going to have to make a right angled triangle and do a little bit of Pythagoras here. So a circle has a radius of 13. So what that's saying is the distance from here to here is 13. That's the key clue usually, is that radius value. So that's 13. I could have drawn it from O to A, but I've gone from O to B. So AB is a chord of length 20 centimeters. Yep. Calculate the width of the shape. Okay, so it's wanting this part here. So what we've got to do is, first of all, we're going to have to calculate this kind of distance here. Oh my goodness, that's a terribly thick line. Let's try, we're going to just use this. So we're going to calculate this distance here. This distance from here to here is also the radius. So that bit we already know is 13. Okay, from here to here is 13. So what we really have been asked to calculate is this distance here. Now the good thing is that's a right angle triangle, and this whole distance here is 20. So that distance is 10, because that's going to be in the center. And we've got two sides of the right angle triangle. So really, if we find this distance, which I'll call x, we can find the whole width of the shape. So x squared equals 13 squared minus 10 squared. X squared equals, and we can just type that into the calculator, 13 squared minus 10 squared, that gives you 69. And we can square root that. That gives us 8.31 to 2 decimal places. So it's 8.31 centimeter to 2 dp. And then we're going to have to add on for the width. The width is going to be 13, add on 8.31. So that's 21.31 centimeters for total width. Okay, great. So that's that question finished. We've completed the width. So quite a straightforward question once you've actually established the right angled triangle. But that is the tricky part. So use the diagram effectively there. Okay, question 13 was like a trigonometry question. Bearings involved. Ooh, everybody's scared of bearings. Ferry and a trawler receive a request for help from a stranded yacht. On a diagram, the points FT and Y show the position of the ferry, the trawler, and the yacht, respectively. Okay, good. So Fy is 7.2. All this information is already in the diagram. You can see it's all here. There's nothing missing. Calculate the bearing of the yacht from the trawler. Okay, so looking at the bearing of the yacht from the trawler, that means we're actually looking for, this is the trawler. So if we're going from the trawler, that means that we're starting here, and we've got to go clockwise until we get to the bearing of the yacht. Okay, so we're looking for that whole angle, the 240 plus this little angle in here. And that's the one it's asking you to find. Once we find that, all we have to do is add 240 on to change it into the bearing. Okay, so we're looking for this angle. We've got all three sides within the triangle, of the triangle, and that indicates that we're going to be using the cosine rule. So cos A equals B squared plus C squared minus A squared all over 2BC. Okay, A is the angle we're looking for. That's got to go here. So we'll call that corner A. This is corner B and C. It doesn't really matter. Ignore the labeling they've given for the question and use your own. A, if this is capital A, this corner, this is small a. B, small b, capital C, small c. Okay, so we've labeled our diagram the way it fits our formula. B squared plus C squared. So we've got the two sides here. The B and the C are interchangeable here because we're just adding them. So if we had them the other way around, it would still give us the same answer. So 5.6 squared plus 10.3 squared minus 7.2 squared all over 2 times 5.6 times 10.3. Once we've got that, we type that into the calculator. It should give us a little decimal answer. So let's do that. So 5.6 squared. Oh my goodness, I can't type. 5.6 squared plus 10.3 squared minus 7.2 squared divided by 2 times 5.6 times 10.3. And that gives us 0.742. And again, we're keeping that answer in the calculator as long as we can. We'll need it for an extra line because we're going to do a second function, or inverse cos. So shift cos and then use your answer button. 42.1 degrees would be the value of angle A. Now that's not quite as finished. The question did ask for the bearing. So the bearing is going to be, remember we discussed this is the angle 42.1 now, 240 plus the 42.1. So it's 240 degrees plus the 42.1 that we just calculated. So it's 282.1 degrees. Okay, great. Question 14. Straight line has this equation. Find the coordinates where it crosses the y-axis. Okay, so to find the y-intercept in anything, we're going to look at the x value being 0. So when x value is 0, we've got 2x minus 50y, 5y equals 20. We're going to substitute in x equals 0, so it's 2 times 0 minus 5y equals 20. That's 0 minus 5y equals 20. And that's negative 5y equals 20. Y equals negative 4. So the coordinate there would be 0 and negative 4. Okay, that's the coordinate where it crosses the y-axis or the y-intercept. Great. Okay, question 15, algebraic fraction. I want it as a single fraction in its simplest form. Let's copy that out again. So it's n over n squared minus 4 divided by 3 over n minus 2. Okay, so the rule for dividing fractions, any fractions, numerical or algebraic, is to flip the second fraction and change it to a times. So we're going to have n, there we go, flip the second fraction, change to times, and then we're going to use the rule top times top, bottom times bottom. So on the top, we've got n bracket n minus 2. We multiply these. On the bottom, we've got 3 bracket n squared minus 4. Okay, now if you look at that carefully, you'll notice that I've not multiplied it directly. I've not gone to the n squared minus 2n because this is factorized form really here, and that's what we're looking for. We're looking to keep the brackets in its a more simplified form. The top line, however, the only thing we could do is multiply it out. That would not be considered simplified, but if we look at the bottom line, the terms inside the brackets, n squared minus 4, are actually a difference of 2 squares. So we can split that one bracket here into 2 brackets, n and n at the beginning to give us n squared, 2 times 2 at the end to give us 4, and 1 plus and 1 minus. Now the reason we do that is we look at the top, the numerator, and the bottom, the denominator. We can cancel this part with this part. The n minus 2 brackets can cancel out. So we've got n over 3 bracket n plus 2 as our final answer there. Okay, question 16. Chris wants to store his umbrella in a locker. The locker is a cupboard with internal dimensions of length of 40, breadth of 40, and height of 70. Okie dokie. So he wants to put his umbrella in a locker. Umbrella is 85 centimeters long. He thinks it will fit from corner P to M. Is he correct? So we're looking to find the distance from P to M. Okay, so that's what it's asking us to do. It's got a three-dimensional kind of shape to this. It looks like it's going to form some kind of triangles. So let's have a look at how we could do that. So the first thing I'm spotting here, and it's quite hard to picture, but if we take another line here, that forms a right-angled triangle with a dotted line in the back corner. So you've kind of got a three-dimensional right-angled triangle here. So sometimes that can be quite hard to see, but you have got a 3D kind of line there, a 3D triangle standing up within the cuboid. So we're going to look at what dimensions we've actually got here. So we're told that this length is 70 for the dotted line at the back. We don't know that. That's what we eventually want to find out. That's the umbrella. Okay, we don't know this diagonal here either. All we're told is that this is 40 and this is 40, but this is also going to form another right angle triangle. So it looks like we're going to have a repeated application of Pythagoras. So rub them out. So we're going to start off with this bottom triangle because we have two sides here. The vertical standing up triangle that we actually want to work with, we've only got the 70. We need two sides to calculate to do Pythagoras. So I'm going to call this first diagonal side on the base of the cuboid x. So x squared equals, and it's the hypotenuse, it's across from the right angle, so we're adding, so it's 40 squared, add 40 squared. X squared equals, so that gives us 3,200, and then we square root that. That gives us 56.57 centimeters. So keep that as accurate as possible. Still got the answer in my calculator in case I need to use it again. So we're saying that this is now 56.57. So I'll try and squeeze that in here. 56.57. Okay, centimeters. On the big triangle, the one that's standing up vertically, the one that we want, we can now do Pythagoras again. And again, it's the hypotenuse we're looking for. If we look at this, the u term, it's across directly from the right angle. So u squared equals 70 squared plus 56.57 squared. And then we can use that 56.57 answer to keep it nice and accurate. So we're doing that square, 56.57 in our calculator squared plus the 70 squared. And that gives us 8,100 exactly. Okay, so we then square root that, and that should give us 90. Okay, so we've got 90 centimeters as the length of U. The umbrella is 85 centimeters. Is he correct in that thinking it'll fit into the locker? Yes, he is correct. Since PM is 90 centimeters, which is more than 85 centimeters. Something along those lines. And that's you got your final mark for your statement there. Okay, great. Question 17. In a diagram below, AOD is a sector of a circle, center O, and BOC is a triangle. Okay, so we've got a part of a circle here, 75 degrees. Sector AOD, the radius is 30. Okay, so from here to here, 30 centimeters. That kind of white part of the shape. Angle AOD is 75. And triangle OBC from O to B is 38. So let's add that into the diagram. O to B, all that distance there is 38 centimeters from the very top to the very bottom. And O to C is 55. So O to C, that whole thing is 55 centimeters from the very top, from O all the way down to the very bottom. Great. And calculate the area of the shaded region. Okie dokie. So it's going to be a sector area to start off with. So the sector area is 75 angle over 360 times pi r squared, so times pi times 30 squared. Should really write out the formula. So angle over 360 times pi r squared. And then that gives us the sector area, 75 divided by 360 times pi times 30 squared. That's 589.05 cm squared. Okay, so the area of this white part is 589.05. We've also got a triangle. So if we look, just imagine this whole thing was shaded in, this whole sector. We've got a full triangle from O, B to C. And it's trigonometry because it's given us an angle with two sides. So we've got two sides and the angle in between. So the area of a triangle from your formula sheet is a half AB sine C. So it's a half times the two sides and the angle included, or the included angle. So times 38 times 55 times sine of 75. Type that into your calculator. Times 55 times sine 75. That gives us 1009.39. Okay, so we're looking for the area of the shaded part here. So that's just the difference between the area of the triangle and the area of the sector. So we just do shaded area is 1009.39 minus 589.05. And that should give us an answer. So taking away 589.05 from previous answer, that's 420.34 cm squared. Excellent. Okay, question 18. We've got cinema sells popcorn in two different cartons, so it's looking like a similar shape type question. Small carton is 16, volume of 576, so V equals 576. 24, volume is 1125. And they're both cubic centimeters. Let's put the units in just for accuracy. And show that the two cartons are not mathematically similar. Okay, so if they're mathematically similar, then once we find a length scale factor and scale it up for the correct volume scale factor, we should be able to calculate one of the missing sides. So what I'm going to do is I'm going to essentially, there's a few different ways you can do this, but I'm just going to pretend like I don't have this value just now, so I don't know that, okay? And I'm going to go through a normal length scale factor, volume scale factor calculation. So we're going to start off with the length scale factor for enlargement. That would be 24 over 16. And then, so 24 divided by 16 gives me 1.5, so 1.5. So it's saying the lengths of these cartons are 1.5. The bigger carton is 1.5 times the smaller carton. The volume scale factor would be 1.5 cubed, and the volume, the missing volume, the one that I'm looking to find, is 1.5 cubed times the 576. So if we take that in, 1.5 cubed times 576, that gives us 1944 cm cubed. So it's saying if they were mathematically similar, the bigger carton should actually hold 1944 centimeters cubed. So we've shown that that is not mathematically similar. Since 1944 does not equal 1125. cubed. Squeeze that in there. Okay, part B. The large carton is redesigned, so the two cartons are now mathematically similar. The volume of the redesigned large carton is 1,500 cubic centimeters. Calculate the depth of the redesigned large carton. Okay, so they're now mathematically similar. The volume of the redesigned carton. Okay, so, oops. The volume of the redesigned carton is 1,500 cm cubed. Okay, so we're looking for the missing depth. Missing depth here is it's essentially asking us for a missing length. So we want the length scale factor. The cartons are mathematically similar, so we've got to find out the missing a length scale factor. The volume of the bigger one, so we're calling it the volume of the larger one, was 1,500. The volume of the smaller one is, what was that again? 576. Okay, so our volume scale factor would be for 1,500 for enlargement over 576. So 1,500 divided by 576 is going to be 2.604. Keep the answer in the calculator because it's rounded. We want to then find a length scale factor, so that's going to be the cube root of 2.604, the answer you just had in your calculator. So it's the cube root that should give us 1.376. Okay, so the length scale factor for the bigger redesigned carton is 1.376 times the original. So it's 1.376 times 1,500. Not times 1,500. That's not the height. The height of the original was 16. So times 16. That gives us 22.01 cm. Okay, good. And that was the last question. Okay, so I hope you enjoyed that video. If you're looking for any more videos for help with some National 5 or higher pass papers, please check out highschoolmaths.co.uk, and please remember to like the video, subscribe, and check out some of the other videos on the channel. Catch you later.